We're continuing with Arithmetic Series, and the word series is basically us talking about the sum. So what's the difference between a sequence and a sum? A series would be, a sequence would just be a list of number, and the series would be the sum of all those entries. So we got a little bit exposed to this before, where, as you recall from previous lessons, that the sigma notation means that you're doing a sub 1 plus a sub 2, and you continue on all the way until you get to a sub 5, because you stop at the top. And so we know a few of these numbers because if you look in the directions, we know that a sub 1 is negative 2. So you have negative 2 plus, well, how do we figure out the next term? Hopefully you're pretty good at this. Well, the second term, if n equals 2, 2 minus 1 is 1, so it's the first term plus 5. So negative 2 plus 5 would be 3. And then the next term, a sub 3, is equal to, well, if n is 3, 3 minus 1 is 2, so it's the second term plus 5. So there's definitely a pattern that happens. Negative 2, 3, 8, 13, 18. And as you add those numbers together, like I said, there is a pattern that happens. 5, add 5. There we go. You should get the correct answer of 40. Now let's explore what you could do to do this problem a little bit faster. And this person actually calls it rainbow addition. And there's definitely a pattern that happens. And so they do a lot of the work with this problem. They tell you it's an arithmetic sequence. So we only do rainbow addition with arithmetic series. The first term is 3, and each next term goes up by 2. So they do the bulk of that work for you. I hope you can see 3, 5, 7, and for some reason they decide to stop at 17. So this is just a predetermined problem that they're adding 8 terms. So as we do this rainbow, there's definitely a pattern that happens, is that as we add on the outside, 3 plus 17, okay, that's 20. Well, let's look at the next sum of 5 plus 15. That's also 20. The next pair of 7 plus 13, that's still 20. And then 9 plus 11, that's still 20. So what's the sum of all those pairs? 20. Now, does it make sense that all of those numbers stay the same? Well, the quick answer is yes, it should make sense. But why? Well, let's think of it this way. If we're adding 2 as we go this way, and we consistently add 2 going in the same direction, as I go backwards, you better subtract 2. So think about if we already know that the sum is 20, and we add 2 to one number, maybe I should write it over here. If I add 2 to one number and also subtract 2 from the other, that it's still going to equal the same thing. So there's a lot of ways that you could say, why does it make sense? To me, it makes perfect sense because it's arithmetic. But you could also say it makes sense because as you add some common difference to one side, you also subtract the same difference on the other. So the sum is constant. So these are your notes, so whatever you feel like writing down is up to you. Now, as we go through, let me just circle all of them. We had 1, 2, 3, 4 of those pairs. Or you could count the number of rainbows, 1, 2, 3, 4. Either way, there's 4 pairs. So think about the quick way of adding things together then is we could multiply. So if we have the sum is 20 and they happen 4 times, let's multiply and the sum must be 80. If you don't believe me, go to a calculator and type it out. 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15 plus 17. Yep, it equals 80. So what does that mean for us? Well, let me put it this way. Notice on this problem that we had 8 terms. I'll write it off to the side. We had 8 terms. And how can you go from 8 to 4 Well, you could divide by 2. And I hope it makes sense that you divide by 2 because there's 2 numbers for each rainbow. So how can we come up with a general formula for an arithmetic series? Well, if we're looking for the sum, so we use a capital S, of the number of terms, you take the number of terms divided by 2, and you have to figure out one of these sum things. And what's easiest for us is to take the first term and add it to the last term. And I could write what n, a sub 1, and a sub n all mean, but it's actually the next box right here. So just a reminder, n stands for the number of terms. A sub 1 means the first term. And a sub n means the last term. And you might be sitting there and saying, well, Mr. Igby, you just did all of the problems with a calculator, wherever my calculator is, and just add them all together. And I said, well, yeah, you could do that, and it's not too bad if there's only 8 numbers. But what if I asked you to add the first 100 natural numbers? Now, if you don't know what a natural number is, sometimes you'll hear people call them counting numbers. They're numbers that happen in nature. That's where we get that name from. But what we talk about counting is you count 1, 2, 3. You never talk about negatives and things like that. So anyway, go through the checklist. Do you know that n is 100? Sure. Do you know the first natural number? Yeah, it's 1. And do you know the last natural number? Well, it would be 100. Now be careful because sometimes we do the first 100 odd natural numbers, so you have to do a little bit more thinking. But the sum of this would be 100 divided by 2, and then 1 plus 100. And I'm still going to encourage you to use a calculator. I think you could do some of it in your head, like 100 divided by 2 is 50. And then like 100 plus 1, you could just write 101. That's what I mean by you should be able to do some of this in your head. But using the calculator just spits out the right answer. Now, the next exercise, each one of these is just a little bit different. And sometimes they tell you everything you need to know. Like this first one tells you n is 16. They tell you by looking at the sequence that it's negative 10. They tell you that the 16th term, so the last term, is 50. They don't always give you all 3 of those pieces of information. And one more thing before I move on is you have to make sure you have an arithmetic series. It'll either say that in the directions or you can tell by the problem that you're adding the same number each time. But you don't actually need that in this problem. So to answer this question, the sum of the first 16 terms is 16 divided by 2 and then negative 10, plus 50. And like I said, you're welcome to use a calculator. You're welcome to do some of this in your head. I think you could do a lot of this in your head because negative 10 plus 50 is 40, half of 16 is 8, and 8 times 4 is 32, so it's 320. If I move on to the next one, now it's going to get more complicated. So recall from a previous lesson, we also had this formula. Because this time as you go through your checklist, we know what n is. So feel free to pause the video and try to understand the problem. We know what the first term is. It's negative 8. But this time we don't know what the 20th term is. Put a little space in here. So that's where this other formula is going to come in. What is the 20th term? Well, I could use that the first term is negative 8 and n is 20 and the common difference is 6. So from this I can figure out, using a calculator, negative 8 plus 20 minus 1 is 19 times 6. Well, the last term must be 106 then. So why do I need to go through that work? Is because then the sum of these 20 terms is equal to 20 divided by 2 and negative 8 plus 106. And again, some of these problems I think you could do in your head, but you're welcome to use a calculator and you get 980. Let me scroll a little bit more. Same thing with the next one. It's implied when they say that the last term is a subscript 12 that n equals 12. They also tell you a sub 12 is negative 29. But do they tell you the first term now? No. So let me go back to that formula that we had. And again, I'm going to use a sub 12 because that's what they tell me. A sub 1 plus n is 12 times the common difference of negative 3. So you might want to just figure out what 11 times negative 3 is. That would be negative 33. So you'd have to add 33 over to figure out that the first term would be 4. And then from here, we could use your sum formula. 12 divided by 2, the first term plus the last term. And it's okay to get a negative sum, by the way. Kind of all over the place with this. Negative 150. And there's one more problem that is, I would say, equally as difficult because they don't tell you what n is. But they do tell you that the first term is 5 and the last term is 77. Well, let's go back to that formula I've been using red so far. So the last term is 77, equals the first term is 5 plus n minus 1. Is it obvious that the common difference is 3? So from here you can subtract the 5 over, and then you can divide by 3. Drawing a blank on what 72 divided by 3 is. There we go, 24. And then add 1 over, and n must be 25. And now we can go to our formula. The sum of the first 25 terms is 25 divided by 2, and then 5 plus 77. There you go, 1,025. I don't know how many of you would rather go through and do 5 plus 8 plus 11 plus 14 plus 17 plus 20 and come up with the answer there. The very last question is really awkward because not very many people would do this, but let's just hypothetically say that somebody did this, where we put $100 into somebody's account, and then the next deposit is $10 more, so 110 plus 120 plus so on and so forth each month for 10 years. So think about it. If there's 12 months in a year and we're doing it for 10 years, that we're doing this 120 times. So just going through my checklist, I know that n is 120. I know the first deposit is 100. Well, do we know the 120th deposit? Not quite. So I've been using this other formula where a sub 120 would equal the first payment, or first whatever you want to call this, and then plugging in 120 in for n, and the common difference is 10. And this is open for debate because I know some people might interpret that a little bit differently. But supposedly the last payment would be $12.90. And again, this isn't very realistic because not very many people would just stuff this into a mattress, so to speak. They'd probably put it into a bank, but that makes the problem more complicated. So anyway, it's 120 divided by 2, and then the first payment plus the last payment. And so let's go to our formula. Speaking of which, I don't know how many people would have $1,290 to put into a bank account. But anyway, let me hurry up and finish this. I'm running out of time. 100 plus 1290, and you end up with $83,400, and you're ready for the homework.